Welcome to GasEd. Today, we're going to look at the exact mechanics of building reliable RAG agents in N8N, and we're going to do it by focusing on one central rule. When a beginner realizes their AI needs to reference external data, their first instinct is usually the same. Take every document they have and toss it straight into a vector database. In chunk-based retrieval, the system shatters a file into tiny pieces, stripping away narrative context. Ask it for the highest sales week, and it scans for that exact phrase, pulling the first isolated match and returning the number inside that single dot. The system never evaluates the surrounding data. Because it only sees a fraction of the information, it delivers an answer that is technically found in the text, but is factually incorrect across the whole dataset. To prevent these hallucinations, you have to practice context engineering. This means explicitly mapping the architecture of your data pipeline to the exact type of question your user is going to ask. The easiest way to determine that pipeline is to use the Human Proxy heuristic. Before you build, ask yourself, how would a human employee intuitively search for the same answer? That brings us to our first retrieval method, spreadsheet filters. This is designed for rigid, row and column tabular data, like a log of daily sales. The operational rule is simple. If a human finds the answer by sorting a spreadsheet for a specific date, you instruct the AI to use explicit filters. The irrelevant rows vanish, leaving only the exact match data points. This approach is highly efficient. It processes rapidly, costs almost nothing in token usage, and guarantees absolute accuracy for rigid queries. But sometimes structured data requires mathematical interpolation, not just exact text matching. That leads to our second method, SQL queries. If a human would need to build a pivot table or write formulas to calculate trends, averages, or revenue rankings, the AI must be instructed to use SQL. This illustrates exactly how SQL solves the problem. By funneling the query directly into the database, SQL shifts heavy computation away from the AI. The database natively calculates and outputs a mathematically precise summary. For structured information, bypassing semantic AI guesses in favor of hard database logic is the only way to ensure fast, mathematically sound answers. Not all information fits neatly into rows and columns. When you deal with unstructured data, like dense text documents and video transcripts, those rigid spreadsheet rules break down. That introduces our third retrieval method, full context ingestion. This is built for deep chronological analysis. If a human needs to read a document from start to finish to properly outline a timeline or summarize a narrative, you must feed the entire text directly into the agent so it can evaluate the information sequentially. This guarantees deep contextual understanding. The trade-off is the cost. Reading thousands of words every single time consumes more tokens, which increases your operational overhead. Which brings us back to our fourth retrieval method, vector search. It is a highly effective tool when used for a specialized purpose. The rule is clear. If a human skims a massive manual to find one isolated FAQ, the AI uses vector chunking. A precision beam instantly highlights and extracts that specific piece of data without processing the surrounding pages. Dealing with unstructured data forces a strategic choice. You have to intentionally decide whether you need to pay a premium for complete narrative comprehension or save costs with surgical isolated extraction. Intelligent routing is the foundation of any reliable RAG agent. Success depends on moving past the habit of dumping data into a single bucket and instead choosing a path that matches the user's specific request. By applying the Human Proxy framework, you explicitly map out how the data should be evaluated. This optimizes your context window limits, minimizes your token expenditures, and protects your data's integrity. Moving away from semantic guesswork gives you much tighter control over the model's performance. A well-engineered context layer provides the specific boundaries and evidence needed to keep responses grounded and accurate. Thanks for watching GasEd. If this breakdown helped you rethink your agent architecture, please leave a like and subscribe to the channel for more engineering blueprints. We'll see you in the next one.